All right, let's talk about something that could be a huge deal. What if you could teach any AI agent new tricks, no matter how it was built, and you didn't have to rewrite it from the ground up? Well, today, we're digging into a really cool new framework called Agent Lightning that promises to do just that. Let's get into it.
So AI agents are already doing some pretty incredible things, right? They can write software, they can sift through mountains of data, they can reason through really complex problems. But for all that power, they keep hitting the same wall. They just stumble when they're faced with new situations, or tools they haven't seen before, or private data they weren't trained on. So what's the big holdup? What's the bottleneck?
So in this explainer, here's what we're going to do. First, we'll break down that big bottleneck. Then, we're going to explore this game-changing idea called decoupling. After that, we'll peek inside the engine to see how it all works, check out the test results, and then finally, we'll talk about why this could point to a future of truly self-improving AI.
Okay, so let's dive into section 1, the big bottleneck. You can think of it as the wall that pretty much all current AI agents eventually run into.
You know, at the very heart of the problem is this basic contrast. Most AI agents today are static. They're like a photograph. They get trained on a massive data set, and then they're just frozen in time. They can't learn from what they actually do out in the real world. The dream, of course, is what you see on the right, an adaptive agent, one that learns from its experience and gets better over time. But making that jump, it's been incredibly hard.
So why is it so tough? Well, for one, creating this super detailed, step-by-step instructions needed for training is just crazy expensive and takes forever. Second, every agent is different. They're all built with unique frameworks, like LangChain or AutoGen. But the biggest roadblock of all is that the existing training methods force you to mash your agent and the training system together. This usually means you have to rebuild your entire agent from scratch just to teach it something new. And let's be honest, that's just not going to happen.
And that brings us to section 2, the decoupling breakthrough. This is where Agent Lightning comes in and totally changes how we think about this problem. It's a fundamental shift.
So what is Agent Lightning? At its core, it's a framework that uses reinforcement learning, which is basically just learning from trial and error, from outcomes, not from explicit instructions, to train any AI agent. And it does this with one single powerful idea, completely decoupling, or separating how an agent runs from how it learns. And this quote from the source paper just nails it. The key phrase here is seamless integration. This isn't just some abstract theory, it's designed to be a super practical solution. The goal is to let developers take the amazing, complex agents they've already built and just plug them into a training system without having to tear everything apart and start over.
Honestly, the best way to think about this is with the universal charger analogy. Remember how for years, every single phone had its own special proprietary charger? It was a total mess. And then we got standards like USB-C. Well, Agent Lightning wants to be the USB-C for AI training. It doesn't matter who built your agent or what framework it uses. You can just plug it into the Lightning framework to charge it up with new skills.
So what does this seamless integration actually mean for a developer in the real world? The answer is right there on the screen. Almost zero. Zero code modifications. This is the absolute game changer. Instead of having to rebuild their agents inside some restrictive training system, developers can just plug them in and get straight to the learning.
Okay, this all sounds a little bit like magic, right? A little too good to be true? So how does it actually work? Let's move on to section 3 and take a look inside the Lightning engine.
The secret sauce is a mathematical concept called a Markov decision process, or MDP. Now, don't let the name scare you. The idea is actually really simple. It's just a way of thinking about any task as a series of steps. Think of it like a board game. You're in a certain state, that's a square on the board. You take an action, like rolling the dice and moving, and that takes you to a new state, where you get a reward or maybe a penalty. Agent Lightning's big breakthrough was realizing that any AI agent's workflow can be mapped onto this simple state action reward cycle. It creates a universal language for training.
Let's make this real with a quick example. Imagine a simple RAG agent. That's an agent that answers questions by first searching for info. Okay, we start at state 0. A user just asked a question. Right now, the system only has one important piece of data, which the framework calls a semantic variable, the user's input. That's it.
Now, the first action happens. The agent's large language model, the LLM, reads the user's input and comes up with a smart search query. That action moves us to state 1. Now our system is holding two things, the original input and this brand new query.
Next up, a totally different part of the agent takes an action.
An external search tool takes the query we just made and finds some relevant information, returning a bunch of text passages. This moves us to state 2. See how the system's memory is growing with each step?
And finally, the LLM takes its last action. It looks at the user's original question and the passages it just found, and it puts them together to create the final answer. And here's the crucial part. Every single one of these steps, whether it was done by the AI model or an external tool, has been perfectly captured as a clean transition from one state to the next. This step-by-step record is exactly what the training system needs to learn. It's beautiful. So this whole process is managed by a really clever architecture. On one side, you have the Lightning server. This is the trainer. It's doing all the heavy lifting for the reinforcement learning, updating the model's brain, basically. And, this is key, it provides a simple OpenAI-like API, which is something every agent developer on the planet is already familiar with.
Then on the other side, you have the Lightning client. This is where the agent actually lives and does its thing. It runs the agent's own code, totally unchanged. And it uses some clever observability tools to automatically capture all those state transitions we just talked about. Every input, every output, and it sends them back to the server as training data. That's it. That is how the decoupling is achieved.
The theory is really elegant, but the real question is always the same. Does it actually work? So let's move to section 4 and put it to the test. To prove this wasn't a one-trick pony, the researchers tested Agent Lightning on 3 really different tasks. They trained a text-to-SQL agent that was built with LangChain, a question-answering agent using the OpenAI Agents SDK, and even a math agent built with AutoGen that uses a calculator tool. So, this covers a really wide range of how agents are actually built today.
And the results? Well, they were pretty conclusive. As you can see from the chart, it didn't matter if the agent was built with LangChain or AutoGen or the OpenAI SDK. Training with Agent Lightning led to clear, continuous, and stable performance boosts across the board. The agents just got better at their jobs by learning from what they were doing. The whole decoupled system, it works.
So finally, let's zoom out and talk about why this is all so important. Section 5. The future is self-improving. Okay, let's bring it all together. The key takeaway here is that by completely decoupling training from execution, Agent Lightning creates a universal plugin for learning. This means you can improve virtually any agent with almost no code changes. And that doesn't just make a developer's life easier, it unlocks the door to a future where AI is no longer static, where it can finally become truly adaptive and learn continuously from every interaction it has with the world.
And that leaves us with one final, pretty profound question. We've spent basically the entire history of modern AI working with models that are static snapshots. But if any agent can now truly learn from its own experience, getting smarter with every single task it performs, what problems that seem impossible for us today are they going to solve for us tomorrow?